Welcome. This is the Echo Modernist Podcast. Our philosophy is based on sound science and free from the outdated dogmas of the 20th century.
Hi, this is Gabe Ignetti.
And this is Eric Schmitz.
And this is the Echo Modernist Podcast. Mark Lynas is a British award-winning author, journalist, and environmental activist. He is a contributor to The Guardian, The Ecologist, The New Statesman, Granta, The Observer newspapers in the UK, and other publications. He also worked on the film The Age of Stupid. He has published several books, including 6 Degrees, Our Future on a Hotter Planet, which was made into a movie, and The God Species, Saving the Planet in the Age of Humans. He's a contributor to The Guardian, The Ecologist, The New Statesman, Granta, The Observer newspapers in the UK, and other publications. He also worked on the film The Age of Stupid. He has published several books, including 6 Degrees, Our Future on a Hotter Planet, which was made into a movie, and The God Species, Saving the Planet in the Age of Humans.
Mark was one of the environmentalists in the film Pandora's Promise, whose premise was based on profiles of people who had switched from anti to pro-nuclear. Similarly, in an activist's role, he had a reversal, switching from anti to pro-GMO technology. And finally, he is also one of the many prominent co-signers of the Eco-Modernist Manifesto. Mark, we're very pleased to have you. Welcome to our program.
You just published a brand new book, Seeds of Science. Could you tell us a little about it?
Sure. It's an exposition of the whole GMO debate, including my own role in it. So there's a kind of broad narrative in the book about my early days as an anti-GMO activist. But I also discuss the origins of the technology, why it came to be so controversial and so strongly opposed in retrospect, what the impacts have been, and I even have a whole chapter about Monsanto, that great internet demon. So I try to not just talk about the GMO issue specifically, but try and locate it in the context of worldviews, why it is that so many environmentalists have been so viscerally opposed to genetic engineering, above and beyond really what the technology in reality means. Because I do think it comes down to values and worldviews. The opposition is a moral one in many cases. So it's a complex issue, but I wanted to try and do it justice from the perspective of somebody who is involved in both sides of the issue.
Okay, well, let's move on to your other books. In your first major work, 6 Degrees, Our Future on a Hotter Planet, you outline the problem with global warming degree by degree. Can you give us a synopsis of what we could expect with each degree of temperature rise worldwide?
Oh, it's a tough ask to do that from memory. That was a synthesis of all of the climate change literature up until that time. And the book came out in 2007. And as it happens, I'm currently engaged in doing an update. So I've recently signed a contract with Fourth Estate, the book publisher, the same book publisher as the previous one. And I'm going to spend the next 2 years immersed in the scientific literature. One thing that does jump out at me is that some of the things that I actually predicted in the first 6 degrees have begun to happen, and in some ways more urgently and earlier than I expected. There was the hurricane that hit Houston, Hurricane Harvey, which was, of course, exacerbated by global warming. The news broadcast bore an eerie resemblance to how I'd written about it in 6 degrees many years earlier. And the same for the disappearance of the Arctic sea ice and also the Great Barrier Reef. All of those were issues which I discussed in the early chapters of the book. How the latest science stacks up remains to be seen, but of course the strength of 6 degrees was the narrative pace, that you start off at 1 degree where the impacts of global warming are relatively tolerable and manageable, and you end up, if we don't take action and we're unlucky simultaneously as a planet, heading towards 6 degrees where it's a catastrophic, cataclysmic outcome. And to consider that could happen within our lifetimes, or certainly our children's or grandchildren's lifetimes, is really quite something. So I know it remains to be seen whether the science has changed, whether we need to be less concerned about global warming, whether some of the new revisions of climate sensitivity are playing out at all. But I suspect that the story is going to be a similar one.
The last hurricane season we experienced had 2 record-breaking back-to-back hurricanes. And they were followed by a Category 4 hurricane, Jose, which luckily veered off into the Atlantic. Now, I know it's kind of vague and speculative, but how many degrees hotter would it have to be, do you think, before becomes the new normal? Or are we possibly there already?
I think we're largely there already. One of the issues which is being discussed in the meteorological community is whether we need a category 6. Some of the super typhoons and really strong hurricanes we've seen in just the last few years have been nudging upwards of that boundary. So, if we need a new category 6, that would be quite extraordinary. And as you say, there's also the issue of tropical storms impacting broader areas of coastline. We could be looking at more impacts in Western Europe, even in the Southern Hemisphere and other places as well. So it's not a great outlook. Perhaps the only mitigating factor is that there's likely to be fewer tropical cyclones overall, even though those that do form are likely to be stronger and they're likely to affect more of the world's coastline and, of course, be exacerbated by broader sea level rise. So most people who die in hurricanes die from the wind blowing debris around. They die from flooding. So it's a storm surge which drowns people, which is the real concern. And of course, sea level rise feeds directly into that.
So how far up the heat scale do you believe that business as usual could ultimately take us, and how long of a window do we have to eliminate greenhouse gases and avoid an irreversible, catastrophic outcome for the planet?
Well, there is a business as usual scenario, which is one of the scenarios that the climate modelers use to feed into their supercomputers to estimate the future course of global warming. It's called RCP 8.5, and that basically projects no emissions controls at all, and the parts per million in the atmosphere heads up towards 1,000 or so by the end of the century, and the resulting temperature rise is somewhere between 4.5 to 6 degrees, in that kind of ballpark. And interestingly, if you look at the projection going even further into the future, it could be 10, 12, 13, or even 14 degrees by 2300. So we'd be pushing the planet into a situation which is probably geologically unprecedented since life evolved on Earth. To see that happen within 1 or 2 or 3 centuries may sound like a long way away to our human perceptions, but it's a mere blink geologically, and I think would be beyond any of the catastrophes that we've seen with mass extinctions in the past. It would probably even outstrip the asteroid that killed off the dinosaurs at the end of the Cretaceous. The question then is, of course, how likely are we to head on that path? We're on it at the moment, but I just don't see how we can sustain increasing coal consumption throughout the 21st century. We're not doing any better than we were 20 years ago. The planet still consumes about the same amount of fossil fuels overall, but I find it extraordinary that we could see that level of expansion of fossil fuel consumption, given what we know and given all of the efforts that have been made towards mitigating climate change.
Yeah, I know the Permian extinction literally wiped out all life on Earth. Of course, not completely, but I was reading that we are capable of exceeding that quite a bit because there's a lot more hydrocarbons that we would be putting in the air than even happened then. If there was a runaway greenhouse effect, the methane and all of that.
Yeah, well, the Permian extinction was a long time ago. It was 250 odd million years ago. So that's far enough back in geological time that there's a lot of uncertainties about precisely what happened and what the factors were. It does seem to likely have been associated with very high levels of fairly rapid global warming. Rapid, I mean, in terms of the geological timescale. And there's been other warming episodes in more recent Earth history. There was one at the end of the Paleocene-Eocene transition where probably what happened, and this is what's really interesting, is that these were volcanic events, huge eruptions of flood basalts, or even the intrusion of magma into coal reserves underground, and those then gas into CO2 and methane. So we have sort of had global warming episodes before, but again, those probably took tens or even hundreds of thousands of years to play out. And humanity's doing this in a much shorter time. We're more effective at mobilizing fossil carbon and turning it into gas than any of the previous geological and natural events that the Earth's likely to have seen, and we're doing it more rapidly. So all of our tailpipes and our power station chimneys and add up to even more than these huge volcanic events did, which were previously associated with Earth's mass extinctions.
Let's move on to your biggest bestseller. In your book, The God Species, Saving the Planet in the Age of Humans, you take forward the work of a brilliant group of Earth system scientists who have mapped out our real planetary boundaries. They are climate change, biodiversity loss, our nitrogen cycle, phosphorus, ocean acidification, land use, freshwater, ozone depletion, and chemical pollution. We've obviously covered the first one, climate change, but could you elaborate a bit on the rest of these boundaries?
Obviously, biodiversity loss is up there with climate change in terms of its scale, its magnitude, and its irreversibility. We're losing species at a rapid rate, and even if we're not talking about actual extinctions, the depletion of ecosystems of wild species, increasingly plants and insects as well. And it's a tragic thing to see, but it was suggested by the Planetary Boundaries team that we're already over the level of what the Earth can tolerate. So we are endangering the ecological balance of the Earth system the more we eliminate the diversity of life. So it's going to be tough because just about everything that humans do affects biodiversity negatively, but it's the most important one. I would consider it on a scale equivalent in seriousness to climate change. Nitrogen was another of the boundaries that the scientists thought we were over. Because what happens in nature is that pretty much all the nitrogen is locked up in the air, where it's N2, so it's not reactive, it's not accessible by life. So if plants want to use nitrogen, of course, which needs to be fixed into reactive forms of nitrogen, which is what happens with the Haber-Bosch process. So that's how humans have learned to do that industrially, to fix nitrogen out of N2 and turn it into NH3, which is ammonia. In natural circumstances, it's very difficult to get reactive nitrogen in the system. A bit comes from lightning, and some, of course, comes from leguminous plants, which can fix nitrogen in their root nodules. But nitrogen has always been a limiting nutrient ecologically, and humans have dispersed huge quantities of it, both in terms of fertilizer runoff and all of the kind of pollution that we make, plus fossil fuel combustion, which also releases oxides of nitrogen, which are reactive. So we've transformed the nitrogen cycle, almost doubled, I think, the amount of reactive nitrogen which is available in the system. And again, that's having ecological unbalancing effects, some of which we're quite familiar with, like the dead zones in the coastal oceans, which come from all the nitrogen pollution which runs down river systems. Then that's consumed by bacteria and causes these big anaerobic areas. So it's another big issue, and it interacts with both climate change and biodiversity. So the thing about these planetary boundaries is that they all kind of talk to each other. So you can't just fix one problem and leave the other ones unsolved. Ozone, we did fix that. Actually, there was a study that came out quite recently that suggests somebody out there is making one of these hydrofluorocarbons. But in general, humanity did address that problem with the Montreal Protocols. So the most sources of ozone-depleting gases have been eliminated, and the ozone layer should be on its way to repairing itself. So I took this as a positive lesson that humanity, coming together as a species in its newfound godlike way, can address these boundaries and can tackle them in a way which solves the problems. But that needs to be done consciously, and it needs to be done intelligently.
Yeah, probably internationally as well.
Yeah, it has to be international activity.
I want to backtrack a little, Mark, to your book that you have coming out right now. Let's put it in terms of the boundaries, right? And I'm looking at this over here. Climate change is the number one. Chemical pollution, fresh water, and land use. Tell us a little bit about GMO crops in terms of those dimensions.
I'm involved actually with the Cornell Alliance for Science and other philanthropic stakeholders in sub-Saharan Africa to try and get drought-tolerant maize available to smallholder farmers in Africa. For that, it's not really about reducing fresh water use, it's about protecting them against drought, because these are rain-fed crops by and large. They don't have access to irrigation. So in a bad drought year, they'll lose their whole crop and families will go hungry or even starve. So being able to have a drought-tolerant crop using that GMO trait would hopefully be able to protect these smallholder farmers in Africa against worsening droughts, which of course are coming faster and more profoundly thanks to climate change. And there's drought-tolerant corn, which is being grown in the Americas. For the climate issue, I don't think it's huge. I think the adoption of GMO crops has reduced carbon emissions from soils primarily and other farming by about the equivalent of taking 12 million cars off the road per year, I think is the latest figures. So it's significant, but it's not enormous in terms of what's been achieved. But of course, most GMO crops were stopped We've only got, on a large scale, cotton, corn, and soy. So there were big plans in the late 90s and thereafter to have GMO versions of potatoes, of wheat and rice and all sorts of things, which, had they been allowed to be adopted, might have really made a transformative impact on world agriculture in a more sustainable direction. In terms of chemicals, the figures from meta-analyses that I've seen suggest that it's about 37% less chemical pesticides used on GMO crops as opposed to their conventional alternatives. And that's largely due to insect-resistant crops like BT. And that's good too in terms of heading in the right direction. The yields are probably better also with GM crops, particularly if they can continue to produce without the addition of large amounts of chemicals. So if you care about land use, if you care about chemicals, if you care about climate change, supporting GMOs would be the natural thing to do. Of course, that isn't what's happened with environmentalism, because as with nuclear, we've inherited a position of opposition, which has turned out not to be based on the facts and has not been amenable to change. So the kind of cri de coeur, cry from the heart, that I make in the book is for an environmental movement which is able to change its mind and which is comfortable with being on the right side of science on all these different issues. We need a science-based environmentalism more than anything else if we're going to solve the planet's problems. Yes, ideology and politics always has its roles. Many of these things are values issues, but in terms of actually understanding the natures of problems and understanding practical ways to deal with them, once you throw science out of the window, you're flying blind.
You've been quoted as saying that ecological limits are real, but economic limits are not. Can you expand on that some?
Well, ecological limits are what's referred to in the planetary boundary. Beyond a certain level, we can't increase CO2 in the atmosphere anymore, we can't deplete the planet's biodiversity, and so on and so forth, without there being really seriously damaging impacts on the planetary system, which of course we all depend on. In terms of economic limits, you hear a lot about limits to growth and some of these kinds of ideas, and they're quite appealing because, of course, at a simple level, how could you have continuing increases in consumption on a finite planetary system? But consumption doesn't have to be measured in weight, if you like. So economic activity can be, in theory, be completely weightless and not have an impact on ecosystems at all in that sense. So what you need to look towards is increasing dematerialization. There's been some trends towards relative increases in efficiency of the consumption of resources already, but we need to accelerate that. I don't think that means overall economic degrowth, though, in terms of how you measure economic activity. So the simplistic notion that tackling ecological boundaries means that we have to stop growing economies, I think does need reassessment.
In terms of advanced economies, it's more a question of rebuilding in a more green way.
Yeah, I mean, in industrialized economies, there's already been probably peaks in certain things because, of course, once everyone's got 1.5 or 2 cars, you're never going to see a situation where every household has 5 or 6. Where would you park the damn things? So it actually becomes a negative to grow absolute consumption past certain levels. I think we're seeing peaking of lots of things. Travel, probably we're seeing peaking of concrete consumptions, wood, maybe paper as well. There's been lots of work on this, which does indicate it's a possibility. So that doesn't stop economic growth because essentially what you can try and do is to build a circular economy where you just accelerate resources faster and faster. Of course, the elephant in the room, if you like, is the need to grow developing world economies, particularly sub-Saharan Africa, South and East Asia, and these parts of the world which are still very much stuck in underconsumption and in poverty. So to turn around to them and talk about stopping economic growth, of course, is not just unrealistic, it's immoral.
The first work of yours that I read was Nuclear 2.0, Why a Green Future Needs Nuclear Power. I really enjoyed that book, by the way. It describes how the anti-nuclear movement in the 1970s and 80s succeeded only in making the world more dependent on fossil fuels. Could you elaborate on that thought a bit for us?
Yeah, I was making the case that the anti-nuclear movement really began in the very late 60s and was at its apex probably in the 1970s and early 80s, made the world safe for coal. Hundreds of reactors were cancelled in the US and elsewhere as well in terms of what was planned. When all those reactors were cancelled, it wasn't that economic growth stopped or that the rising consumption of electricity stopped. What happened was that all the energy companies switched back to fossil fuels, and coal in particular. And so we've been stuck with a legacy of thousands of coal-burning power stations precisely because, to an extent, the anti-nuclear movement stopped the increase in nuclear power. So they talked about wanting solar power and they talked about wanting wood fires. And it was a very sort of backward-looking, impractical vision that the anti-nuclear activists had in retrospect. So all that happened was they managed to stop building reactors and leave the world open for more fossil fuel consumption.
It sounds like the austerity philosophy has put us in a bad place.
Well, if you're talking about energy austerity, yes, because that isn't what happened. I mean, people didn't reduce the overall consumption of energy. It just came from a different source, namely coal. I did in the book try to do some back-of-the-envelope quantifications, and some other people have attempted this as well. But you could say that the anti-nuclear movement's given us a quarter to half a degree of global warming. But it's anybody's guess because, of course, we don't know what would have happened otherwise. But the evidence is there. There's reactors which were half built. They just turned the reactor hall into a coal-burning boiler, and the anti-nuclear people went away satisfied. So I don't think anyone can deny that the anti-nuclear movement or the environmental movement at that point did facilitate the rapid growth in coal consumption, and thereby, given that coal is the biggest source of greenhouse gas emissions, gave us a significant extent of modern-day global warming.
Do you see a change of heart coming about to any degree? Things look promising a little bit?
Well, I don't detect much softening in the environmentalist scene towards nuclear for different reasons. I don't think it's as visceral the opposition as it used to be back then. But now, of course, there's other arguments like the economic ones. Because you've had this regulatory ratchet and everybody's so terrified of nuclear waste and radioactivity, it's become really impossible to build at a reasonable cost the standard pressurized water reactors in all of their various designs. So it's going to be increasingly difficult to see how nuclear can be a part of solving climate change. And the environmental movement hasn't helped by changing its mind on this. I don't think Greenpeace wants to see a future of cheaper nuclear reactors which can help solve the climate problem. It wants to see just wind and solar like it always has done. So I don't see much softening of positions there, even amongst those who say that climate change is the most important challenge that humanity's ever faced. They don't seem to want to reconsider their ideologies about things like nuclear power.
Michael Schellenberger's very recent article in Forbes about the used fuel issue. So many think of it as a problem that needs a solution, and that it really is not a problem. And when we speak in terms of a solution, we're feeding that narrative.
I've read the piece. He makes the point that the nuclear is the only energy industry which actually has to secure its whole waste cycle, and that the amounts of waste that are produced is trivial both volumetrically and ecologically. After a bit of time in the cooling pond, they get stuck in dry casks in these canisters, which get stuck out the back next to the parking lot, and you don't have to do anything about it. And even solar produces toxic waste, where it's not clear where the waste from these PV panels is going to end up, of course, and Michael loves talking about this. And there's no overall responsibility for that. Of course, the waste, both in terms of carbon dioxide and ash and all of the other pollutants from coal burning and other fossil fuels, doesn't even bear talking about.
You mentioned about this new environmental movement. How does that come about? Do you see any kind of path to reaching that goal of a more sensible environmentalism?
Yeah, I mean, I still consider myself an environmentalist, first and foremost, and I consider myself to be working with colleagues in the wider environmental movement, whether I agree with them on certain of these issues or not. I'm quite happy to work with them and to celebrate the work that they and other mainstream environmental groups continue to do on many issues. So I've never wanted to kind of split environmentalism. I think environmentalism, of course, we have to remember has done a lot of good in the world. We can breathe fresh air and drink clean water, and certainly in industrialized countries, as a result of environmental campaigns of the past. And we can see reforestation in many areas, and in some places, wildlife is bouncing back. And polluters are under great pressure, and the same goes for climate change. And we have to have a strong, thriving environmental movement to be able to do this. So let's be clear about who our allies are on all of these issues. But then the environmental movement has always been a broad-based thing, has included lots of different perspectives. So I think eco-modernism can be one of them within the broader framework of the environmental movement as a kind of progressive voice, really, one which is more science-friendly, more techno-optimist, one which has a progressive worldview, really, in terms of being able to see things in the future as potentially better than what we've experienced in the past. So for me, that's what's interesting about eco-modernism as a concept, is that it does bring up politics, it does bring up values, it does bring up some of these things which we often just brush under the carpet when we have these debates about nuclear power or GMOs or whatever they happen to be, because ultimately those are moral debates. When I was writing the Seeds of Science book, I went back to talk to my anti-GMO colleagues from the past to try and figure out what it was that was the primary motivator for them now, and probably me in the past. And it was that, really. It was a sense that humans were transgressing technological boundaries, that we were messing with nature, that we would have to pay for this sort of technological hubris and those kinds of things. And those are about your worldview, really. I don't think you can say that science can prove it one way or another in the here and now. Obviously, scientific evidence will accumulate in the future, but whether you're optimistic about what technology can deliver or pessimistic, those are all strands of thought you'll find within the environmental movement.
So you were not always an eco-modernist. When was your moment of epiphany?
Yeah, I think in the past I've been fairly dark Malthusian type environmentalist. I sometimes think about this, about how I used to think that a world with many fewer people would be a good thing, and it's difficult to square that with a concern about human rights and concern for individual liberties and things. So I think some of that kind of Malthusian environmentalism is quite in tension with universal democratic values. And that's interesting. To the extent that I've resolved it at all, I'm on the side of modernity, in the sense of believing that human rights is a universal concept. It's not relative to which ethnic group or which culture you happen to be from. And that goes for the rights to self-determination in terms of your gender and sexuality, things like that. And I think those are part of what environmentalism needs to be. But undoubtedly, those are modern concepts. Those are things which arose out of the Enlightenment. And so the robust defense of Enlightenment values, I think, is an important part of that as well. And for me, that informs my vision of what environmentalism should do and what kind of future we want to build, which is a future which is both able to protect the non-human inhabitants of this planet, as well as deliver a higher quality of life and safety and liberty for the human beings too. So I think that's something which is worth fighting for, and I think it's probably a vision which is shared by a lot of people, whether they call themselves environmentalists or not.
My moment of epiphany was Fukushima. When that happened, I started really taking a look and educating myself, and I've actually written and done a speech called How Fukushima Made Me a Nukie. So, yeah, interesting ways that people come to change their mind.
Mark, I got a question. I run across environmentalists who say it's all over. It's just too late. And what do you say to that?
Yeah, I hear that too, and sometimes I feel that. Sometimes people, confide in me in the pub and say, "I just think it's too late." But I say, too late for what? Yes, it's too late to limit climate change to 1 or probably even 2 degrees, but it's not too late for 4, 5, or 6. So I don't think there'll ever be a point where we say it's too late, it's game over, because then what do you do? Do we all commit mass suicide? Do we sort of hunker down in some kind of survivalist dystopia? So it's not even a useful concept particularly. It's been explored to some extent culturally by the Dark Mountain Project, which I think made a wise decision to do so in sort of now in stories and in poetry and things, to try and understand what that might look like. But I don't think it really leads anywhere. It takes you to despair, and it takes you ultimately to a kind of immobility where you lose faith in our ability to solve the problem. And if we can't solve the problem, or if you don't feel motivated to solve the problem, then that's as good as deciding that we are going to face these more catastrophic scenarios. I mean, that's probably the thing which is most guaranteed to take us into the high degrees of global warming, is if enough people decide that it's too late to do anything and stop bothering.
What would you say in closing?
I think some of it comes down to your personality type as much as anything. I'm a kind of a pessimistic optimist. I try and be pragmatic about things. But ultimately, you have to live your life as an optimistic way. If you've got kids, I've got 2 kids, and I can't reconcile myself with the idea that the future for them is going to be unlivable, then how could you continue to bring them up in the way that you do? So having children is about being hopeful for them and for the future. And that's the way that I prefer to live my life. And I think that eco-modernism perhaps is a more comfortable place to be if you're a hopeful, progressive, optimistic person, but you're still concerned about the planet's ecology. We really could solve these problems using enough nuclear power stations and renewables and all of the things that we all know need to be used to address the problem. Somehow politics and other things keep getting in the way, and I don't think it always has to be the case. I think we will probably come in at 3 or so degrees of warming this century, and it'll take a huge, huge amount of effort for us to even restrain climate change to that level. So we all need to get on and do it.
Okay. Well, it's been a pleasure having you, Mark.
I've thoroughly enjoyed this.
No, well, thanks for the invite. It's been good to talk.
And now for our final thoughts. We'd like to repeat the words of Mark Lynas, and it can't be said enough. We need a science-based environmental movement more than anything else if we're going to solve the planet's problems. And that is precisely what the Eco-Modernist podcast is about.
Wishing for this is not enough. It can only happen when you take action. We at Eco-Modernist Communications have put out a line of shirts with just that message. You can start by buying them and wearing them proudly.
And that new environmentalism starts with us. We don't need to reinvent the wheel. We need to fix it. So what we are saying is that the next step is to take those shirts, put them on, get out there, and get involved.
It's really easy to sit in our armchairs behind our computers and say that we are the only true environmentalists. But you can't talk the talk unless you walk the walk.
We need to get off Facebook and get on face-to-face.
If there's one thing that history has taught us, it is that the path of least resistance is the road to hell. It's time to stand up and be counted.
And that's it for our show today. And just to remind our listeners, if you want to purchase any of our shirts or make a donation, you could go to ecomodernistpodcast.org. This is Gabe Ignetti.
And this is Eric Schmitz.
We're leaving you till next time.